Hi guys, welcome back to Data Every Day. Today we are looking at how to use sklearn's pipeline for incorporating pre-processing into the model so that you can feed in non-processed inputs to get predictions. And we will be looking at a data set of employee data, and we'll be trying to predict the employee attrition, or whether or not an employee will leave the company or not. So at the end of this data set, we have this status column, which is active or terminated. There are voluntary and involuntary terminations in here, but we're not going to worry about that. So let's hop into the notebook. I'm using NumPy and pandas for working with the data. And then these are what we're going to use for pre-processing. We have the train test split function from sklearn. They're all from sklearn. We have pipeline, column transformer, and then Ordinal Encoder, one-hot encoder, and standard scalar from the pre-processing section. Then we will have our model, which is logistic regression. So let's go ahead and import all of that, and we'll load in the data using pandas.readcsv. So we can go up and grab the file path up here with this CSV file, paste that in, and we can take a look. So this is, I think, a great data set. It is a synthetic data set. It's a fictitious / fake data set, but still good for educational purposes. And it's a good data set to use pipeline for because we have a lot of mixed types of columns here. So let's get a little more information with data.info. Looks like we have no missing values. We also have 13 object columns and 5 integer columns. So let's get started. We're going to do some initial pre-processing, which really just consists of the train test split and dropping a few columns that won't be used in the predictions. So what we want to do here is get our data into the form that we'd like to pass into the model, but it does not have to be machine ready. It does not have to be encoded as a proper numeric vector with no missing values. This can be sloppy data, but as long as it's the right columns that we're looking for. So I'll create this function, preprocess inputs. It's going to take in a data frame. It'll make a copy of the data frame and then return the data frame. So actually what we want to return at the end is all 4 sets for our data. So why don't we just do the train test split to start. We'll split df into x and y. Y is going to be what we're trying to predict, and that's going to be the status column, which is whether they were terminated or not. And then x is all the rest of the data, so I'm going to drop status from x as 1. Then we'll do our train test split, and that's going to put 70% of the data into the train set and the other 30% into the test set. And we'll use the train test split function from sklearn, pass in x and y, specify the train size, which will be 70%, include shuffle equals true. This is on by default, but just so we know we're shuffling before we make the split. And because we are shuffling, we're going to include a random state to ensure the shuffle is always made in the same way. Then we will get our 4 sets of the data back, which is xtrain, xtest, ytrain, and ytest. And that is what we'll return from this function. So we'll run that, and we'll get them back over here with preprocess inputs. We'll pass in data, and we can take a look at xtrain. So right now xtrain is just a copy of data, but let's look through this and try to figure out which columns we don't need. So we want to consider the situation where this model is actually being used in production, which means, okay, we want to predict status. It's not on here. Let's look up at data. We want to predict this column status. If we were really trying to use this in production, we would want this model to be able to predict make a prediction about an employee who's still working, to know whether they're likely to be terminated or not. And because of that, we have to make sure we remove any columns that were recorded after the employee was terminated. For example, a termination date. This is the date of termination. You can see if they weren't terminated, which if they're active, then we have January 1st, 1900. But this column, first of all, it gives away information about our target, which is no good. It's a form of data leakage. because you could think the target data is leaking into our data set, which will give us inaccurate, well, it'll give us better predictions than we should be getting. So we're going to drop this termination date column. Let's look for other ones. So length of service. This is a bit debatable. I would say to drop this. The reason is we have the original hire date and the recorded date. So I'm not saying that with us, we're going to be using a logistic regression model. So there's no guarantee that that model will be complex enough to capture the relationship here. It might, but it technically, for a human, there is enough information in this data set using just the recorded date, the original hire date, and the length of service column to figure out if the employee is terminated or not. Because all you have to do is take the recorded date, take the original hire date, add how many years of service, and then see if it's less than the recorded date or not. And that will basically tell you if it is if the employee was terminated. So we're going to want to drop this. We could also drop one of these, but I feel like this makes the most sense to drop. City name's good. These are all good. Store name also good. Everything here. We have 2 gender columns, so we'll just drop one because it's duplicate. And then these 2 we definitely have to drop. This is the reason for termination and the description about the termination. And we can't leave those on because they give away information, like I said before. And if in practice you were using this model, you wouldn't have access to these variables. So let's do this. We're going to drop, first let's drop the unnecessary columns. And the unnecessary columns, I just mean columns that, well, there's really 2 of them. Employee ID, we don't need this because they're all unique identifiers. Actually, look at this. These are from the same employee. Regardless of this, we do want to drop this column. I think it seems like it's taking yearly reports about the same employee. We still want to drop this though because we want this model to be able to perform on any employee. And if we pass in an employee ID that the training set has not, that the model has not seen during training, it's not really useful, right? So this column is not going to help us. We're going to go ahead and drop it. And the other one I want to drop is, I believe, one of the gender columns. We have 2 gender columns. Might as well just drop gender short. Doesn't really matter, just as long as we only have 1. Alright, so that dropped those ones. Now we'll drop these columns that were not available before the termination. Drop all columns not available before termination. Because like I said, in practice we will not have access to those columns. And that would be the termination date, length of service, and then these 2. Termination description, termination, it's a termination reason, termination type. Alright, and I'm dropping these from axis 1 as well. And here we go. So here's our final data set. This is what we would pass into the model if we were using it in practice. Now it's not encoded yet, it's not properly preprocessed, but this is how you'd want to enter information if you were wanting to make a prediction. Now enter the pipeline. Pipeline is extremely useful for making it easy to feed in these kinds of human inputs that make sense to humans, right? Words, numbers that are not scaled, just proper inputs in the form that the data was originally recorded. and then feed it through the pipeline, make the prediction, and then return it based on something like this instead of passing in just pre-processed data. So pipeline, let's say building pipeline. Alright, and there's a few things we have to do. We have to, so basically the way pipeline works, I imported it at the top. It takes in a number of steps. And that's going to be a list of tuples. The tuples are going to be pairs of the name followed by the transformer. And what I mean by transformer is there's a bunch of transformers in sklearn, like the Ordinal Encoder. There's some imputers like simple imputer, which will fill in missing values. We have one hot encoder. You get the idea. There are these classes, and what makes them all similar is that they all have a fit function and a transform function. Now the fit function is used for looking at the train set and taking in any useful bits of information that it might need. For example, for one hot encoding, it would look at all the unique values and would store those with the fit function. Then the transform function is the function that actually changes the data based on the fit. So anything we pass into the pipeline must be a transformer. Now I must also point out that we also have a model which also is passed into the pipeline. So a model goes at the end. That's going to be, in this case, a classifier. So that would be our logistic regression model. Pass that in, and maybe we can give it a name of classifier. This can be anything you like. So now we want to feed in the pre-processing steps before we make the classification. And it will run through the pipeline in order, in the order that we make it. So let's sort of divide the types of features we have here. So looks like we could have 2 or 3 different types. A good way to get a sense of this is by taking xtrain, which are train set, and typing .select dtypes object. And this will give us just the object columns. Since the integer columns here, age and store name, and status year, we already know they're in proper form. We don't need to do anything except scale those for the model. So these are the ones we have to encode in some way. And we can get a sense just by looking at it, but even a better sense maybe by creating a dictionary that maps a column name to the number of unique values, which we can get, I'll use xtrain. We can get that from xtrain subcolumn .unique and then take the length. For every column in this list of object columns, so that thing .columns. I forgot the n. Okay. Alright, and now you can see the number of unique values in each one. So the first 3 are date columns, and we'll handle those separately from all the others. So we'll consider those as date features. So let's actually write this. Let's put it down here. Date features. It's going to be a list of all our date features. That's going to be these 3. And I'll just put them on their own lines. Alright, there's our date features. So then we have these ones, the remaining ones. And we can tell after this what kind. First we want to check, is there an ordering to their values? And maybe even before that, we want to check how many numbers they have, how many values they have. And what I'm looking for is these 2's here. When a column has 2 values, we use binary encoding, which is just very simple. We send one of the values to 0, it doesn't matter which one, send the other one to 1. So 1 will be 0, 1 will be 1, it will just be a binary column. These 2 are binary columns, binary features. So let's put those here, binary features. Alright, good. And then the last ones are city name, city name, department name, and job title. So these 3. And now we want to ask, is there an ordering to the values? Because then we'll use ordinal encoding. If there's no ordering, we'll use one-hot encoding. And by looking at these, we can clearly see there is no ordering between any of these values. They're all independent of each other. So we're going to use one-hot encoding for all three. And such columns with more than two unique values and no ordering between them will be called nominal features. So let's put that here, nominal features. And that's going to be these three. Okay. Alright, and we have our list of features. These are all 8. We have 2 here, 3 here, 3 here. Now we need a way to deal with them. Now let's make a comment. Classify features by type. And now we're going to construct transformers to handle each type of feature. So for binary features, sklearn already has a nice transformer built for us, which will be the ordinal encoder. The ordinal encoder will just look at a column and assign each unique value to a random integer. That is as long as you have categories equals auto. If you care about the ordering, you can specify a list here with the values ordered as you like. So this is going to be how we'll deal with the binary. So what I'll do is I'm going to construct this binary transformer, and this is going to be a pipeline. The only steps here will be this. So this is like a sub pipeline, right? Then we'll have our nominal transformer. Whoops. So this one, we'll call it nominal transformer. Oh, sorry, this should be a tuple, like I said, but we have to name it. So I'll call this ordinal. And then this one, this will be nominal. And we're not going to use ordinal encoding here. We'll use sklearn's one-hot encoder, which will do the one-hot encoding for us. Don't have to specify that. And that's it. This is going to take care of all the encoding for us for these two feature categories. Now for date features, there isn't really a great built-in way to do this with sklearn's classes, so we're going to make our own class. I'm going to call this date transformer. And the date transformer, we don't even need to give it an initialization function. We can just give it a fit and transform functions. As long as it has these two, it's a valid transformer. Now for fit, we don't actually have to fit anything here. We're just going to return self. Oh, sorry, I should pass in self here. It has to take self, x, and y, and this one takes self and x. So we're just going to return self because we're not going to save any data when we're doing the date encoding, and I'll show you why. So essentially the transform function is what we're looking at. Transform function wants to take a column. What x actually is being passed in here is a data frame with all of the date columns, only the date columns. So let's simulate that. We'll take xtrain.loc all rows, and then the columns we want are date features. Date features. Oh, we run this. Alright, so this is the kind of input that transform is going to take. So what can we do with a data frame like this to extract all the information we need? Basically, we're going to use pandas.toDateTime. And this can take in just a timestamp as a string and turn it into a datetime object where we can actually then get the year with .year, the month with .month, the day with .day, etc. Now you can see the minute and hour and minute data is not actually in there, so we're just really concerned about day, month, and year. Now it looks like they all have the same here. We can actually verify this like so. We take xtrain, take the record date.key, turn it into a datetime object. So the toDateTime can also be used on columns. And then apply a function that takes just the years, the months. So x becomes x.month. And then we ask, are they all equal? So equals 12, and then dot all. And no, so there are different ones in there, so we're going to leave it. Okay, we're just going to extract the month, day, and year from every single one. From this column, and this column. So like I said, we can pass in a whole column here, and it will transform the whole column into a datetime object column. So in our class, first thing we want to do is for every column in x.columns, remember x is going to look like this. So for each one of these columns, we're going to take that column and call pandas.toDateTime on it. And once that's done, so let's simulate that here, pandas.toDateTime. No, sorry, that won't work. This is a good idea. So after it's been converted to datetime, it's going to look like this. How can we take the year out? Well, we can apply a function to it, like I did before, which just maps every x to x.year. And then we'll get the years. And these are already as integers, you'll see, so that's nice. So let's do that up here. This is for a given column. We're going to make a new column called the old column name plus underscore year. So if our column coming in is record date key, this column will become record date key year. And that's going to be equal to the old column with a lambda function applied that takes in an x and returns x.year, like I did before. Then we'll do the same thing for month and day. So this and this will become month. And over here, this and this will become day. And then when we're done, we can drop, so x equals x.drop, the original column. Since it's still a string, we don't want it anymore. We've essentially handled it with this. And then once this is done for all columns, we've gone through this for loop, then we can return x. And this is our date transformer. This is all we need. So let's put this up here. Just say, let's build a transformer for date columns that will extract extract the year, month, and day features. Alright. Now done here, our date transformer is going to become a new, we'll do a pipeline like this, except this will be date, and this will be date transformer, new object. Alright, and we have constructed our 3 methods of encoding for each of these columns. And now what we'll do is use them all together. We're going to build a preprocessor or preprocessing transformer with column transformer. So column transformer allows you to take different pipelines and apply them to specific columns. And we'll call this preprocessor. This will be our main building block in the pipeline for preprocessing. And this will be a column transformer from sklearn. And here we specify all the transformers with a list of tuples similar to the pipeline. The name of the first one will be binary, and that we just pass in our binary transformer that we created earlier. And then we specify which columns we'd like to apply this transformer to. And that will be our binary features. Then we will do the nominal, and that's going to be using the nominal transformer, and apply that to our nominal features. And then last is our date. This will be using the date transformer that we created, and we'll be applying it to our date features. Alright, and that's it. I would like to also point out, I'm just going to include this argument, sparse threshold equals 0. This will ensure that the output is returned as a dense matrix instead of a sparse matrix. And that just because I was, just for the sake of our purposes, I want to keep it this way. Okay, so I'm running that, and then we'll build the final pipeline. Alright, so this is our model. Now you can call it model, you can also just call it pipeline if you like, but essentially this is a pipeline, and now we group all the steps together. So we're going to start off with our preprocessor, and that is the preprocessor we just made, this one. Our next step is going to be scaling the data. So after the preprocessing is done on all three types of features, we'll have fully numeric data and it'll be ready to scale. So we'll include a standard scaler, which, as you probably know, already has its own fit and transform functions. And then we'll have the model, or I'll say classifier. And this is going to be logistic regression. And so what this will do is take the original data that looks like this, it'll pass it through the preprocessor, get it fully numeric, then scale it, then make predictions on it, and return the result. Alright, so let's try this. Training. Let's fit the model to our train set. Model.fit xtrain ytrain. And while that's running, we will get the results. So I'm going to get the, here it is, it finished. You can see first it applied the preprocessor, which consists of all this, the different transformers we created. Then it does the scaling, then it does the classifying. So we'll get the accuracy value with model.score on the test set, and we can print this out, test accuracy. We'll display it to 2 decimal places as a percentage. Format that with accuracy times 100 since it is a percent. And see what we get. And we get 100%. Now, I was a bit suspicious at first about this, but I did try it out with different models, and some models are giving a little under 100. Now, I don't think there's any data leakage here. I'm pretty sure we're using a good set of features. If any of you catch something that I'm not seeing, please let me know. But it may just be that this is a synthetic data set, and 100% accuracy isn't really too special on a synthetic data set. But that's nice to see. Now, one last thing I'd like to do is show that now why this is useful. We can create a sample input. Let's say I have a dictionary. I just copied this from my other notebook. These are all of the features that we use and the actual values that we're entering. And these values still make sense to us. So I could input this to our model in its current state, and because it has the pipeline, it will actually just give me a prediction based on these values that make sense to me. So let's call this sample input. And this will just be a pandas series. Now once it's turned into a series, I do want to turn it into a data frame because the predict function for sklearn will require a data frame. So pandas.dataframe, actually it may take a series, but I'll just structure it this way. We'll turn it into a data frame and then transpose it so that it looks like this. Just a single record on our test set. Then we'll call model.predict sample input and store that in prediction, and then print out model prediction and prediction. And you can see it actually tells us active. Now if we go ahead and change these, let's look at X-test. What's one that has, I'll look at Y-test as well. Can't see it. Okay. Xtest.query. No, that won't work. Okay, Y-test equals, what was the other one? Terminated. Index in Xtest. And now we can see the terminated ones. So let me just take one of these. I'll enter in the data for it. So the record date is 6-1-2006. The birth date is 6-28-1944. The original hire date is 1-3-1993. The age, 65. The city name, I'll just copy it in. The department name is dairy. Job title is dairy person. The store name is 12. The gender is female. The status year is 2006. And the stores is the business unit. So if I run this, I should get terminated because it's actually exactly matching a record that was terminated. And there it is. So you can enter any information you like here, and as long as the values you're entering were in the original data. And yeah, so that will sum up today's video. So thank you so much for watching. I hope you enjoyed it. If you did, make sure to subscribe and hit the bell for more content, and leave any comments you have in the section below. I'll see you guys tomorrow. Have a fantastic day.